Hey there, thanks for tuning in. This is 1.2 Network Topologies, and this video builds on the 1.1 networking overview. So this is where we start getting into more of the detail in regards to network topologies. So let's go ahead and get started. In this video lecture, I'm going to talk about some key terminology that you're going to need to know, especially if you're preparing for the Network Plus, the CompTia Network Plus certification. Network topologies, we'll look at the physical versus the logical network, and then we will look at types of network topologies. So some of these are pretty dated. We don't see a lot of these anymore, but we still see them showing up on the certification. So basically a topology is an arrangement of elements of a communication network. Okay, pretty simple. It is the form and function of how the network is created or how the network is formed. So you can see here, we'll get into these in detail, but you see this one has a main backbone. You know, this star connects to a central hub. We have a ring, and we'll go through the rest of these. Mesh, tree, point to point. We'll look at these in detail. Remember that these can be both physical, meaning cabling, and today modern networks would leverage 802.11 technology for wireless. So the first thing we need to know about network topologies is there's this thing called a local area network. It's essentially a network that is in a small geographic area. So I've given you an example here of something that might be a network that you have at home. So especially if you have interest in this topic and interest in taking the Network Plus certification, you most likely already have set up a home network. You probably have a router with a switch that provides wireless into your home that connects via a modem to an internet service provider, or perhaps the modem is built into your all-in-one router switch here. You're probably connecting devices like smartphones, laptops, desktop computers. You're connecting your smart TVs, printers, so that anyone can share and print, maybe even a gaming console. So one of the things that makes this work is that each device on a network is going to be given a unique IP or internet protocol address. I give you an example of a common one down here. Most of the consumer grade home office devices that we would buy, say at the box stores at Costco or Walmart, or get online at Amazon, are going to be default configured with a Class C Internet Protocol address, usually starting with 192.168, then either 1 or 0. Okay. Now, in the last thing, we talked about a subnet mask, and this is the default subnet mask for a Class C. With this subnet mask, we're only going to have one network available. Okay, we can go ahead and change this by using this last octet to create multiple Class C networks so that we can do what's called subnetting, which we'll get into in more detail. Now, in order to do this, this device here is going to have its own IP address. Notice 192.168.0.1. I used 1.1. And what happens is all these devices are going to route traffic, thus a router, out to the internet. So anything floating to the internet is going to float through this address out to a public IP address that is routable to your ISP's network, and then finally out to the internet. So some things we need to look at. First of all, again, some of this technology is dated, but we still see questions to understand the basics of what networking used to be. So what I'm looking at here is a bus network with PCs connected, and the way these were connected was with thick coaxial cable, just like the cable that may run into your house for broadband internet. So it's that black cable, you know, with that single copper wire inside. And what we would do is we would put terminators which absorb the signal on the ends, and that way when a computer communicates back in the old days with these networks, it would communicate out over the wire and ask everyone on the wire, hey, is this data meant for you? And before the terminator, it would just float data back and forth. Hey, is it you? Is it you? Is it you? And keep asking that question. What the terminators do, as soon as that data packet hits the end of the wire, it's terminated so that it doesn't fill the wire with traffic. Okay. Now keep in mind that I'm using really basic terms because this is an introductory network course. As we talk about networks, we're looking at both the physical and the logical. So the physical is the placement of various components like the cable, okay, like the terminator, and like the devices that manage route traffic or switch or hub traffic, okay? While the logic illustrates how data flows. So when we're talking about physical, we're talking about the devices. When we're talking about logical, we're talking about the packets and the protocols, such as TCP/IP, that allows data to be transferred over the network, okay? Communicate with one another. Logical topologies describe how signals act on the network. So that's what we're talking about here. These are both same but different. Distances between nodes, physical interconnections, transmission rates, or signal types may differ between two different networks, yet their logical topologies may be identical. Meaning, we may have a bus network, okay, or a star network that utilizes the same equipment, okay, or different equipment, such as a star utilizing a hub versus a bus utilizing a main line, but the logical is going to be the same. So here's another example down here of sort of a logical network. And when we're talking about logical, think about the IP addresses, think about the protocols. So let's quickly look at some network topologies. First off, actually this should say point-to-point, or as we know it to be peer-to-peer network. It's a topology, it's a simple topology. It connects two nodes. So this is connecting one computer with a network interface device to another. And we do this through a special cable called a crossover cable. So this needs to be configured not like the default cable which is a straight or through cable that you might buy, down at your, at your local Best Buy, okay? This cable has to be custom wired so that two computers can connect with each other without a hub or switch, okay? In simplex mode, signals flow in just one direction. You could see how incompatible that would be, but as you remember, in our ring network, simplex mode means that the communications will only travel in one direction, and that's pretty important on a ring. The next type is a bus. Now you saw this already, and we looked at these terminators, okay? We looked at both straight through connections, we looked at a terminator, we looked at T's. So this is how a computer would connect. This would go right here, this would connect into the computer, and this would connect to that main line that you see here, okay? So a linear bus is a common transmission media which has two endpoints. So this would be a linear bus, and we'd have an endpoint here. This is another example here. Notice we have a terminator and a terminator, okay? In a distributed bus network, all nodes on the network are connected to a common transmission. Now, what I do suggest is that you pause and you read through these as I'm explaining them, okay? It physically distributed bus topology functions in exactly the same fashion as a physical linear because all the nodes are common. So notice here we just have a bus and a bus and a bus, and they're all connected. Okay, so if we started traffic from this computer, it would go out both this way looking for its receiving computer. Who needs the data? It would go here. It would ask these computers down here. It would go here and ask these computers. Hopefully what you're seeing is imagine the game of telephone, and how efficient that game was, where you had to, send a message to many people. Okay, now unlike telephone, this message would stay consistent, but it's going to go to everyone versus going to the single computer. If data was sent here and needed to go here, that we would see, okay? And we'll see how we've improved on these technologies. Ring technology is a bus topology. It's a closed loop, okay? Again, traffic tends to flow in one direction, okay? Around the loop in one direction. The intermediate nodes repeat or retransmit the data to keep the signal strong. So every time we hit that, or if we have a long run, we would put a repeater in there to strengthen the signal so that it can make its way to the next. So if we have data that starts here at the top computer and needs to go to the bottom, it's going to go through this and through this and through this before it gets here. So hopefully you can see the inefficiencies in our old network technologies. So when the load on the network increases, its performance is better than bus technology. Why? Because it's not flowing in both directions. Okay, and because we can keep the ring small or not keep the ring small. There is no need for network server control, the connectivity between stations, again, because it's a single flow. We're not having to worry about communications going backwards. The problem with this is it's bottlenecked by the weakest link between two nodes. So again, remember I said, if we have a long connection and the signal degradates, then that becomes a bottleneck and slows down the ring. Now, where we went from there is to a star. Now, a star network utilized a thing called a hub. A hub should not be confused with a switch. So when we talk about a hub, what we're talking about is essentially if a computer connected here on, say, port 5 needed to connect with a computer on port 1, it's still going to do the same thing. It's going to ask the computer on port 4, hey, is this your data? Port 3, is this your data? Port 2, is this your data? Port 1. Finally, port 1 says, hey, that's my data, and they can communicate. Now, when it sends signals back, it says, did you want this return message? Did you? So with a hub, we're sending the information out to everyone. So imagine being in a room and you only want to communicate with one person, but you're having to basically disrupt the conversations of everyone else in order to get your message through to the one person that needs it. Finally, there's the tree. The idea behind the tree, it is a hybrid technology, meaning that it's going to use multiple bus networks connected to, a main. You could call this the backbone and subbones of the network. They're again probably going to connect with a hub, which again means that every computer is being asked, hey, is this your data packet? Do you need this? Now, modern networks utilize a mesh network. Now, when we talk about a net mesh, I'm going to take you back to our original graphic of a local area network that you may have in your home. And the idea here is that in this router is also a switch, not a hub. Remember, a hub communicated with every port on the hub. A switch has a routing table that says, I am going to send information from 192.168.0.101 right over to the printer at .11. I'm not going to ask anyone else. I know that this packet needs to be sent right there, so you can see the efficiency. And the cool thing about this is now suddenly connections are made between every device connected to our network. Now, what we've done with mesh, so that we didn't have to run wires all over our house, is we've gone to a Wi-Fi mesh network. All of these computers or devices have a wireless network interface card that can communicate with the wireless access point and thus create a wireless mesh. Finally, hybrid, so uses two or more technologies. This is the idea that we might have a bus connected to a star, connected to a ring. Okay. Now, we don't see hybrids much anymore because the default network topology that we're using is going to be that mesh network, either wired or wireless. And we continue to improve the feature, functionality, and throughput of wireless to make it more efficient. So that's enough for this lecture. Hopefully you enjoyed it. We'll see you in the next one. Take care.